welcome to the WiDS Datathon First Place Winners Call. This is Maggie from Kaggle. I'll turn it over to Sharda.
Welcome. We're really excited to have you here. Congratulations on being first place winners. It's a lot of hard work that's on in, and we are so excited to hear your story, what you've done, and all the steps that you've taken. So first of all, I'd like to sort of invite you to introduce yourselves, your team, what you're studying, where you're working, and tell us, how did you meet? How did your Datathon team form? And then we can go into some details. Thank you.
I'm on the global WiDS Datathon team and the WiDS Worldwide program, and I lead lots of the communication efforts. And it's just a pleasure to meet all of you and hear about your experience this year on the Datathon.
Sure. I'll share my screen for the slides.
Sounds good.
Yeah. So this is the agenda for today's presentation. We'll start with the background summary and then move on to feature selection and engineering, and then the training methods, then some of the important findings, and then what was our simple best model. And coming to the background, team leader Mathurin Aché, I think. Do you want to introduce yourself?
Yes, of course. Thank you, Usha. So let me introduce myself. My name is Mathurin. I'm 41. I live in France. I'm a very regular user of Kaggle since the beginning. I'm currently ranked 25th in competition one ranking in Kaggle. I'm 18 years in data science, 15 years in Orange, first French telecom operator, and 3 years at Prevision.io, an automatic machine learning software editor. And with my teammates, we have participated in Women in Data Science competitions since 2019. Usha?
Yeah, sure. So about me, I'm also the WiDS ambassador for Mysuru chapter, and my educational background is I have a very strong domain knowledge in financial engineering, marketing analytics, and life sciences. And before becoming a data science, I have a background in investment banking. And once I started my data science journey, I was lucky enough to get work in different projects, which involves very niche fields like semiconductors, genomics, telecommunication, finance, and public policy. And so currently I head the data science research at XR Protocol, which is a blockchain-based startup. The data science part in the blockchain startup involves, using AI for cybersecurity, detecting frauds, and detecting outliers from entering the XR network. So this is me. Over to Jerome, and he is also a very expert, experienced Kaggler. Over to you for introducing yourself.
You're on mute.
Jerome, are you there?
You're on mute.
Hi everybody. Sorry for that. I'm Jerome. I'm also working at Orange, where I am a former colleague of Mathurin. So we met there and start working on some Kaggle competition together, and also with some other colleague. We already participated in previous Datathon. So it's really a good opportunity for us to work together on extra domain and interesting problem actually. And that's pretty much it. Zeineb, you can go ahead if you want.
Yes. So I am Zeineb, and I am Tunisian. I'm 29 years old. Basically, I have a telecommunication engineer degree, but I wanted to go into the data world. So I completed my education with a big data and data mining at Paris. Once I got my diploma, I have been working at Prevision, where I have known Mathurin. It's a startup that produces an AutoML product as a SaaS solution. And now, since the beginning of this year, I am working as an ML engineer at another startup, Hexagon IA, that is working on decoding human behavior via AI algorithms. So I started playing with Kaggle since my friend Mathurin encouraged me to participate with him at WiDS 2019. I really appreciated the sharing. It is really a great place to learn, and we can find an infinity of notebooks produced by really highly qualified people all over the world. Then I have known Jerome and Usha through Kaggle and through Mathurin.
Yeah, sure.
That's really wonderful. And one of the things at WiDS is we meet people from all over the world, and it is really a privilege. It's really wonderful for us to meet people so qualified, so educated, so passionate about machine learning and AI, and to see how many years of study you've invested in this field. So that's really wonderful.
Yeah. So a few more questions regarding the background. What made us decide to enter this competition? The reason why all of us are strong advocates for diversity and inclusion. That is one of the reasons. And the second reason is this year's challenge deals with AI for climate change. So it's very good to come together to work for a social cause. And it's also 2030, United Nations 2030 SDG goals as well. And so these were some of the reasons why we came together and worked for this competition. And all of us spent around 5 hours a week, individually for this competition. And the reason why we decided to team up is we were part of the same team last year as well. And so we have, continued the same partnership in terms of team formation. And I personally have seen all of them, my teammates are active Kagglers. So I used to meet them in leaderboards of different competitions. And it's good to team up together for a social cause and contribute. And with regards to who did what in this competition, I contributed to extensive state-of-the-art research and also implemented several research paper implementations. Zeineb tested out several algorithms, and she proposed very clever and efficient blends towards the end of the competition. And Jerome proposed scripts mixing exhaustive models with lags. And then he also proposed models without lags after pseudo labeling. And from Mathurin, he iterated very quickly at the beginning, and he came up with a lot of very interesting inference performance. And he was a person who pointed out to the AutoML approach. He was trying out H2O and various other AutoML approaches, which were very, very crucial part of our winning solution. This is the distribution of who did what in our team. And over to Jerome for describing the summary of this entire competition.
Yep. Okay. So yeah, as far as I remember, the keystone was really to first to do an extensive exploration of the data to understand what was going on and how we can maybe leverage some ideas from that. And basically what was really important was to try to identify which building was there for a couple of years and which building was only there for 1 year. So we can do some like time series, short time series analysis on that. And once we found that, we understood that we can make some lag feature about it. And maybe also what we did and work well was to do several models for different case of building information we had in the data. So that was basically our strategy on this. And also we built a lot of feature. some were useful, some were useless. And I guess Zeineb can talk about that now.
Yeah. So the next important part is the feature engineering. Over to Zeineb to cover the feature engineering.
Yes, as Jerome said, the keystone of element of our first place is the feature engineering. So actually, we used past values features to apply some aggregations to end up with relevant features. So first of all, we suppose that we can extract some weather-based features like the number of cool or hot days. We aggregated these features on different meshes by season or by year, and then we applied aggregation functions like min, max, average, standard deviations. So that's the first one. Second, we also tried so the Usha does that. Yes. Second, we tried we tried out some logical building-based features like averaging the unit floor area to the whole building or dividing the rating stars by the number of floors, which we suppose that it would make sense. Also, we used the group by based features extractions, which is a technique that we use every day as data scientists. So we apply some statistics on some grouped data by energy or rating stars or by location and merge these grouped values to the overall data. Usha, the second feature, yes. Furthermore, we applied some more sophisticated operations like lag-based features, which take values from previous time. We went up to 3 years past time. Example, the energy usage and intensity of the building 1, 2, or 3 years ago. We extracted these features as new features with and gave it to the model. Also, we used other techniques like rolling based or moving average features. Also, a very efficient one is the delta based features like the evolution rate or the difference of the feature consumptions between the current and the last year. So as you can see, we highly went into the feature engineering part. As we can see here, the most predictive feature, it's not surprising, is the value of the last year energy building consumption. Then the second one is the facility type, which is not very surprising because the consumption depends on the type of the facility. Then we can find the other lag-based features of the previous of more previous years. So the second one, yes. So here we wanted to visualize the potential dependency between the most powerful features and the target. So as we can see on the plot, we can note that the building the lag the last year energy consumption is quasi linear with the target. The second one. Also, we did the same for the second top feature, and as it is shown, that it is reservedly dependent because the less the energy rating is, the higher the consumption, the energy consumption is, which takes sense.
Yeah. Thank you, Zeineb and Jerome. The next up, we have what are training methods which we used. A quick snapshot of the training algorithms which we employed for our final solutions were a lot of AutoML libraries, and AutoML libraries were some of the integral part of these solutions. And we also experimented with linear regression techniques, CAD boost, and LGBM as well. And the best we retained the best of the regression gradient boosting models like the CAD boost, LGBM. And when it comes for ensembling techniques, the techniques which actually work for us are the weighted average ensemble and the blending ensemble. And we decided the weights based on our intuition, partially based on our intuition, and some of the insights we got from the AutoML as well. And this is a quick, snapshot of our training pipeline. We have our training data. Then we did the feature engineering techniques with Zeineb elaborated. And we also tried out various feature transformation techniques like the one-hot encoding, scaling, and all that. And for the AutoML, we tried Prevision.io and the H2O. And these were the AutoML libraries which we tried out. And we also tried out several gradient boosting models like I outlined in the previous slide. And from the AutoML, we also did post-processing, and then the gradient boosting models also we did, individually post-processing. And all of these submissions were finally, we did a weighted average ensemble of all of these submission files. And this is what our training pipeline looks like. And some of the important insights and findings are the feature engineering, as Zeineb mentioned, it is some of the very, very crucial part for the pipeline. And this played the critical role, I would say. And there were different feature engineering techniques which we employed, and all of the techniques mentioned by Zeineb in the previous slides. And we mostly the feature engineering techniques, particularly based on historical site EUI, and the rating star values were giving us a very, very significant enhancement to the model. And when it comes for ensembling techniques, like I mentioned in the previous slide, the techniques which worked for us was weighted average ensembling technique worked for us. It was able to capture the distribution of efforts and diversity of the underlying models really well. And when it comes for post-processing techniques, as much as feature engineering was crucial to our pipeline, post-processing played a huge role as well. And there were several post-processing techniques which we employed in the pipeline, which played which played a crucial role in placing a winning solution. And next to the post-processing techniques, the other techniques which really played out well were based on different types of models. We use different types of techniques, whether we decided whether we should use lag values or not. For different kinds of models, we did employ lag models, but for certain kinds of models, we did not. And so these kind of manual, classification and employing of techniques also played a very important role. And finally, and the most important, AutoML. And AutoML was something which made our jobs very easier. We were able to quickly iterate and quickly find out some of the very important features AutoML was able to show us as well. And so AutoML was also very, very crucial for us to get a very solid baseline early on in the process. And some of the interesting diagrams from our notebooks which we created are, I'm just going to show a couple of snapshots of some of the interesting diagrams which we got in our notebooks. The one on the left side is the correlation heat map between the important features like the year factor, flow area, and year built, energy star rating, and all of it. And the other side, you have the light GBM, the most important features from the light GBM model. And finally, one very, very important thing which we noticed during our model building exercise was we found out there's a very strong linear relationship between the site UI variable and the previous site UI variable. So this helped us in smoothing the final predictions which we got. And for the previous site UI variable, you can derive it using the formula mentioned here. And so far we discussed what things work for us, and there were a few things which we tried and it did not work out that well. And so now I'm just highlighting some of the techniques which did not work out well for us. The weather-based features did not work out really well for us. We extracted lots and lots of weather-based features, and it did not contribute much to the model building process. And we also tried out several fancy imputation techniques like the KNN imputation and all that. It costed a lot of resources and time, but it did not contribute much as well. And there's one more technique, like removing outliers was not that efficient. Compared to post-processing techniques, this outlier removal was not working out that well. And finally, adversarial validation also did not work out well. So once we found out certain features, once we were able to spot the drifted features, what we did was we removed these features and we rebuilt the model as well. So these were some of the techniques which did not work out that well for us. And when it comes for the single best model, our single best model was ZUJM, the H2O prevision.io, which was giving us a score of 18.5. And the top features from single best model were energy star rating, facility type, year built, elevation, floor area, and the state factor. So yeah, we're done with the presentation. Over to the questions.
For sure. I think this is really impressive. Thank you for taking the time to sort of walk through the process. I mean, of your thought process and your really hard work that's gone into this. It's really wonderful to hear that. We hear all your hard work. I was just wondering a couple questions. Do you have sort of details of the performance of the other models that you looked at? Is there sort of a marginal difference between the other models, or do you have a table of all of the other models that we can look at just as a comparison? And number two, the second question that comes to mind is I really liked your heat map, your correlation structure that you looked at. Did you look at the changes in correlation structure over the time period at all to see how that might have affected your performance, or is that something that you looked at? And the third question that's just a question coming to my mind was something like this is you've done a lot of research, a lot has gone into it. Are there questions in your mind, that are kind of unanswered, that research questions that you would like to further work on, that you think that might have just gotten started with this line of research? If you could continue working on the model infinitely, what would you work on? What other aspects, are kind of more questions that you had? So those are my three immediate questions. Does that sort of make sense, or no?
Yeah, we want to try to answer. I will have one answer regarding the performance of other models. They were pretty close as far as I remember. Yeah, it's not a big gap between different models once you have the feature correctly computed. Either you use a CAD boost or a light GBM, or even a regression was pretty good at giving a good score. And yes, what we can improve maybe is we actually didn't found any good feature related to weather, for example. And since most of good feature were based on lagged and the previous consumption, I'm not sure we are learning a lot of things from that in terms of improving improving weather, improving consumption. Maybe it would be good to only use one state of building, or I don't know if you have, if my colleague has some ideas about that.
Yes, actually, the question about if there is an enhancement of the performance of the model. Actually, we tried out, as Usha mentioned, we tried out the adversarial validation, which basically compare the data drift between the train and the test dataset, and we try to detect the features that drift a lot between the train and the test. Then we remove these features, or try to change them so that it can be more like the test dataset. It's a typical Kagler technique, but it didn't work, even though we used it in the last weeks, and it worked. But in this WiDS competition, it didn't work. So also, as Usha said, we used also some more sophisticated missing values imputation, like KNN imputation. It didn't work. We can suppose that if we add some other additional features from public data sources, it can enhance, but we didn't try it.
For sure. Are there any sort of further research questions that you would like to pursue? I mean, are there any technical areas of research that this sort of inspired you to pursue?
For the other areas of research, one thing which always struck me was I was working with a lot of state governments, particularly for developing smart city traffic management system, and there were other projects. The way I could connect those projects with this is one thing which I predominantly noticed in all the government projects was the techniques which work really well in very developed countries like Europe and United States with the kind of data. The same things did not work for India. So because the kind of road conditions in India is very bad, and certain features, the projects and the models which worked outside may not work really well, and we struggled a lot and to bring a solution which might cater well to the Indian road conditions and which might work and give a benefit. In India, there's a lot of cultural societal indicators as well, so certain cultural flags which we had to induce into the models. And so I'm also currently working with the Indian government for the export trades and policies and giving them insights. So they also discuss regarding the climate change. I'm just wondering how much of these insights can be applied to the Indian conditions, because in India we don't get these kinds of data, like the kind of building data which you get, and so many of these features, that kind of a data is not available in India. So how do we go and adopt these kind of research models which we have come up for countries, still developing countries like India? Like it's always been plaguing in my mind. That's something which I want to explore in the future.
For sure. I think that's definitely very credible, and that's definitely a very, a fantastic outcome of a modeling competition.
Actually, in the phase 2, we want to explore. So typically some deep approaches, but we are pretty that the gradient boosting models are more sufficient, are more performing in this type of data. So we can try this solution of deep learning. Why not? Even though we know in advance that our approach is better than the deep learning approach.
And as Usha pointed out, it has tremendous implications for countries all over the world. In India, the United, all countries are doing this. So having to, being able to build these models that are applicable to different countries, different problems, I think it's really, it's very timely and it's very, very important. So one of the, we wanted to give people the opportunity to get their hands dirty with this kind of data, so they can think about it and absorb it and really take the challenge in, because this is not a challenge that one person can solve. It's a global problem, and there's a lot of. Sorry, go ahead.
Also, yeah, from the literature, it is saying that maybe the number of people living in a facility can affect the consumption. So maybe it would be nice to have a proxy or the information of how many people are living in the house or in the building to check this out.
Yeah, it's definitely. I mean, this was a data that was provided to us by CCAI. And they are constantly, updating their data sets and getting data sets that are more and more, richer data sets. But it's not easy to build the data infrastructure, the entire data pipeline. You did a lot of variable imputation. Part of the thing is actually getting a really good data set and build rich models, and you say, okay, well, I need this additional data set, data variable, and then you go get it and you build your pipeline. And this is an iterative process.
I'm happy to jump in.
Yeah.
It's insightful to hear everything that the team has to share. I had a question, since we do have so many beginners that participate in the Datathon challenge. I was wondering if you had any advice to share for first timers or beginners in the WiDS Datathon.
Well, actually, me, I consider that I'm a beginner. I have, to be honest, I have much more less experience than Jerome and Mathurin and Usha. But the fact of participating in a team, even though they do better than you and they are more efficient, but you can contribute, you can build upon their work, and I'm sure that the fact of ensembling or the submissions is very efficient.
Yes.
So.
Yeah, I work with a lot of beginners, and currently also I'm working with a lot of interns as a part of my work. So one thing which I always noticed was even I would particularly quote the Kaggle BIPOC program, where I was assigned a mentee. So I worked with her for 3 months. So initially my mentee was very scared to participate in Kaggle competitions, and she was like, she's very talented. And the fact she was an undergraduate student at the time when she was assigned as my mentee, but then at that time itself she was placed in Microsoft. So she is very talented, but then she was very scared she was scared of competitions. She didn't want to compete. She needed that push, the initial push, and she won the bronze medal in the first competition she participated. So she has all the talent and all the skills, but then there's a lot of fear and there's a lot of hesitancy to come out and try. And even in the Kaggle leaderboard, even if you had noticed last year's leaderboard, there were a couple of students who were 10th grade students, and all the school students also participated, who were very first timers. And even in the history of Kaggle, I've seen in the reinforcement competitions, particularly the simulation based reinforcement, there was a school student who continuously won 2 solo goals continuously in the consecutive reinforcement competition. So there were a lot of women who are talented and beginners who are talented, but for some reason they're not coming and giving it a try. So all they require is that initial push. Once that is given, and they're brilliant, they do great things. This is what is my experience with the beginners whom I've worked with.
That's really fantastic. I mean, the whole point of WiDS, we are focused on breaking down barriers. I mean, when we started off, I mean, women didn't really, a lot of women are been doing technical things for a long time, but they haven't there hasn't been this critical momentum, getting women from the very beginning, from the earliest stages of the pipeline, and getting them into this, technical field, and giving them the confidence, giving them the resources, telling them you can do this, don't worry about it, we're here, having a lot of, sessions all over the world, workshops, really giving them resources so they can absorb this information and go and run with it. And we have beginners and we have advanced people and we have researchers who are also like you said, who are working on research papers. So we have the entire spectrum. So and it's really a great joy for us to see people start from at the very beginning, like Usha said, and then kind of put their try things out and get comfortable and build more and more complex models and start thinking about the mathematics and start thinking about the sort of what's happening at on all these different models, and then underlying technical level, and then move over to research. And so this entire transition is very interesting for us to watch, and we see this like you mentioned across the board from people, women and men all over the world coming in, and we see a lot of networking, we see transitions. This is just, it's really wonderful for us to see. And so how are you going to use this going forward in your own lives, this experience? Any thoughts?
Excuse me, I didn't.
How do you plan to use this experience in your own lives going forward? Do you plan, now that you built a model, you won first place, and you built all these different models, you have all these questions, how do you plan to use it in your own life going forward?
Basically, I use I like a lot Kaggle because I can use the code source in my daily job. And I had the chance to participate with the champions here that are great grandmasters, and so I consider that it is a great opportunity to learn, especially to learn and get some tricks that can make the difference between you and the other colleagues in your work.
Others?
Yeah.
Mathurin, you haven't spoken much. Any thoughts from you?
Mathurin?
Yeah.
Yes, of course. Kaggle is a great place to learn, of course, to share between us, between previous colleague, and to try on the different sector and different data. We cannot use in your daily job this kind of problematic. It's a chance to try your competence on this new challenge, and to learn and share.
Yeah.
That's right.
I haven't heard too much from you. Any thoughts about the model building or challenges that you had? Or I know you did a lot in the model, but any first person thoughts or challenges or anything about the models and things that you did?
Yes, it's great. It's a chance for us to do on this kind of subject, because to be useful, it's really important in your competence. So in your daily job, we do some commercial objective, but societal, humans objective, it's important for us. With Zeineb and Jerome, we participate in a French association, Dessine-moi la high-tech. We help doctors to diagnose cancer for children. And this kind of subject is not your daily competence use, but to help some kind of subject like this, it's really important for us.
For sure, for sure. It's great to hear that. Very great to hear that.
And
Also,
to add that Mathurin offered to us the baseline model, which was the first place, and then we built upon his model.
yes, yes, I know this is really fantastic. Yeah, a really good job. Also invite Maggie, who's our fantastic partner from Kaggle, who's really instrumental, a foundation for everything we do here at WiDS. Maggie, do you have a few questions you want to ask?
You know, I love the questions around, you know, one thing that is important to us is trying to break down any perceived barriers on entering Kaggle competitions, because we get to see the benefits of people building their machine learning profiles and their data science profiles by participating in Kaggle competitions. I mean, you know, we hear these great stories about how people are in PhD programs and then not getting interviews, and then they participate in Kaggle competition and then they'll get some good score, even in the tabular competitions where there's no points, no medals, and the data sets are intentionally accessible. So this person wrote into us and said, oh, I participated in a tabular competition and I did well. And then people started pinging me on LinkedIn. So we want it to be a place where people feel comfortable building their data science profiles. So, you know, if you ever come across feedback of like, oh, here was something unfriendly, or maybe moderation activities we can do, or other activities we can do to be, you know, make it more welcoming. Because once you participate, we hear, oh, wow, I asked what I thought was a dumb question and people were really helpful, but it's taking that first step, right? Asking that first question and starting to participate. So feedback like that would be helpful for us, because we are always looking to reduce the barriers for people to participate.
So I can respond to that. To be honest, it can be efficient in America, but not here.
Why is that?
Yes, it doesn't count so much in your CV. If you are a Kaggle master or grandmaster, novice, it's not very. But actually, for me personally, I participate in Kaggle, especially for the notebooks and sharing the notebooks more than the competitions. To be honest, and I want to share and the source codes and discover the new techniques. It is very important to be up to date in our domain. And yes, and I think that Kaggle is a great place to be up to date all the time, especially where we can find notebooks shared by very highly qualified people that works on multinational
data sets, right?
Yes.
And I was just on a call earlier this morning with a 4-time grandmaster, and he says he comes to Kaggle to learn, right? So, you know, it's a place where you can try new things and learn. So that's great to hear that you're getting some of those things out of it. Do you have feedback for Kaggle on things we could be doing to, you know, kind of make it easier to get the things out of it that you're interested in?
Feedback in WiDS or Kaggle platform?
Just, I mean, anything. Right. I mean, because I think obviously we're hoping to do another WiDS next year. So like feedback for that, or just feedback in general.
Yeah.
Yes. Actually, in the at the beginning, I found that it is very hard to appear as on the leaderboard. But it was a good idea to democratize this with medals that you offer with to data sets or contribution or contribution.
Discussions, right.
The contribution, I found that it is very very good to do an excellent idea. So this part is very important. Also, nevertheless, I found that it is quite difficult, even with this system, to appear. But once you get you are a master in any field, it's worth. It's well merited. So
that's great.
That's really fantastic. I think for us at WiDS, I mean, we put in Kaggle, we put in a lot of effort to get to this point, to prepare the data set, to get all these workshops, get all these resources, put it on the Kaggle platform. There's a lot happening behind the scenes to get to this competition too. So we are really thrilled to see the effort that you have put in. I mean, we have people all over the world, thousands of people all over the world compete in this competition, and the passion and the energy that we perceive is just really incredible. And our goal, like has been said many times, to break down barriers and get women and get people into this field, and get them the confidence and the knowledge and the resources so that they can themselves advance their careers, advance whatever it is that they want to do, and go forward. So we see that you all are doing that, and you've done a fantastic job. So congratulations on a fantastic performance. Congratulations on being the winner, and doing such a hard work. It's a tremendous work, and getting together a team where everybody participated, everybody pulled contributed to this. So, and that's really impressive. It's really wonderful to see that everybody, this is a very, very strong team, and you had that great performance. So congratulations. Thank you for all of the efforts that you put in, and we hope to see you again in future competitions. We hope to see you in research, our phase 2, and we hope to see you again and again as we build at WiDS, and as our program continues to grow. And we hope to also see your involvement in our things like workshops and things that we do in WiDS. So we will invite you to join us. So that's definitely look forward to hearing from us. We're not going anywhere.
Thank you.
Thank you so much, and congratulations again.
Yeah.
Thank you.
Thanks to you.
Thank you.
Thank you.
Okay.
Thank you very much.
Okay.